Doing a little repair here on images that we took of some NGEN disks. This particular image is the 11.3 standard software workstation utility disk 6 of 6, 71-03140-06. Now, the way this worked is I was using a 720 kilobyte drive, or I should say one that's set for 80 tracks, but at 300 RPM instead of 360. And so that's supposed to be 720 kilobytes formatted. And this drive seems to have some problems here on this head close to the center of the ring. And it just gets progressively worse every time we read it. It doesn't get any better. So I was using a different drive, one that's set for 360 RPMs. Of course, that's designed for the IBM standard 1.2 megabytes at 80 tracks. It read the same data, but of course the bit rate is off. We can't emulate it with those settings. We have to change the settings. But then we had an additional problem. This entire track right here just refused to read on multiple tries, and I don't know why. It's track 77, I believe. Let's have a quick look here. All right, so that's the one there that we have issues right there in this region right here where we have some bad data. So we're going to clean that up. We're also going to, what we're going to do is we're going to put those other two images together. But I just want you to see the anomaly of this one here. This one was just a really strange thing where this happened on a couple of these disks, and I think it's just for some reason the fact that I'm reading it at the wrong RPM. That one track just doesn't like it. It's track, let's see, that's track 36. So that's track 37, and there's track 38. Yes. So if we go to our track view, 37, that's side 1, which is fine. We go to side 0, it says nothing's there, even though you can clearly see the MFM looks just as good. But somehow, for some reason, it's not interpreting it, so it's not going to be able to convert it to the proper data, and therefore it's not going to be able to emulate it. So we've got to fix that file, and we're going to do that manually here. So with that said, let's put this back on dummy disk. You got to see that. What we're going to do is, let's go to our comparison here. This is an image file that I made so that I could look at what's going on. I'm going to, we're going to take, I think what we're going to do is we're going to take this image and find out where this section is right here. And then we're going to splice in from here on to the end so that it's nice and clean. And that should be a way of putting these two together where we have this side good, this side bad, this side bad, this side good. But the way disks work is it's not side 1 plus side 2 where you go through tracks 1 through 80 on side 1 and then you go back on tracks 1 through 80 on side 2. Or in this case, I really should say side 0 and side 1, but you get the point. It's track 0, side 0, track 0, side 1. Track 1, side 0, track 1, side 1. Track 2, side 0, track 2, side 1. So you see it goes back and forth, and that's what makes up the file. The sectors are sequential, but the tracks are not. They alternate sides. Okay. That's my understanding of the way floppy drives operate, and maybe even hard drives, but we'll get to that later. All right, so what we're going to do is we're going to convert both of these to raw image dumps, and this one is going to be completely missing the entire track worth of data. It's just going to skip right over that track, and so the entire disk after that's going to be wrong because not only is the data going to be the data is going to be missing, but then it'll move up the data after it into the place where this should be, so the positions are going to be wrong. Whereas this one, the whole thing should be good till about this track right here. So I guess what I'm going to have to do is we're going to have to load that image here, and I need to identify what track that is. So let's do that. Let's pull up the track analyzer here again. So it is at track, it's actually this very sector that we have a problem with. So this is, yeah, see what we have here is a bad CRC. It's actually a bad data CRC. We have the head CRC is okay, but the data CRC is bad. I don't know that I've analyzed that deeply on floppy drives because this stuff is so well managed by other software like this, like the visual floppy disk here on HXC. By the way, yes, the tool that I'm using is the HXC. It gives us some nice little bit tunes there. Chip tunes, bit tunes. But anyway, this is what I'm using, and I find it an absolutely excellent tool. I mean, look at this. Disk image visualizer. I think it's awesome. Okay, so this is track 59 where we start to have the problem, I think. Yeah, because 58 seems okay. 57's okay. 58 is where we start to have the problem because that's where I'm seeing the bad data CRC. I point to it with the mouse, but as soon as I move the mouse, what's over here on the right goes away. So we're going to have to take care of that in editing if I've edited this video, and chances are just to get it up so that the people who care about this manual repair actually get to see it sooner rather than later. My apologies. Okay. Anyway, you get my point. Where was I? I was getting lost. That's a different one that I did the same procedure on. So this is going to be the more complicated one. All right, so let's get each of these files exported to IMG. Now IMG is a purely raw sector file format with no header information whatsoever, which is actually exactly what we want. We just want to dump the entire contents of the file. It's not an IMD, which is compatible with Dave Dunfield's image disk. That's kind of been the standard before we had tools like the CryoFlux and the SuperCard Pro and the Grease Weasel and that kind of thing. We do have those tools. We can capture magnetic flux transitions now, and we can make these kinds of conversions and manipulations because we have HXC software to help us do the conversion, as well as KEIRF, or Kerr Fraser, has done some fantastic job with this. We're using HXC. Kerr Fraser, that's another advanced level we'll deal with another time. Hopefully I can even interview him for Forgotten Machines someday soon. Anyway, we digress. All right, so we're going to export this to an IMG file right here. And so let me do that. And then let me open the other one, which is this one right here. All right, that's the right one with this one bad track here on side 0. We're going to export that also to an IMG raw sector file format. And now I already have my operating system set to open IMG files in HXD, hex editor. And so we're going to start with the file whose beginning is good but end is bad, and then open the file whose beginning is bad but end is good. And so we're going to be able to see here, let me change these to decimal because my brain thinks in decimal more than it does in hex. So we're going to see that these are different length files. So this one actually should be a full track shorter, 6218 192. This one is not a full track shorter, but it's some sectors shorter. So this one should be longer, but still not the proper length. And so let's see here, 626656. 626656 as opposed to 628. Right. So I guess I'm wrong. They're both too short. 626 is shorter than 628. All right. So this is missing more than one track's worth. It's just we don't know where. All right. So this is where it's going to get pretty tricky. So this one, we have to find out where it's going to be bad. Now, because of the way this export works, it just skips the bad sectors and moves on past it. Just ignores them, which is a problem. What that means is I have to manually find the bad sector before this. We should be able to do that, right? Sure, we have the tools, we have the brain power. Let's make it happen. So let's open this one right here. And let's find that, and let's identify it by the track contents. We should be able to do that, right? Okay, so let's pick this right here, 57, right? So if we go to 58, yeah, see, this is where we start seeing the problems. See where that turns pink? We got some bad sectors there. So actually, I could even, assuming these sectors are unique, I could even look at this right here, and I wonder, can I copy this data if I get, no. See, as soon as I mouse off this, I don't know how to copy this data. See, this is where it's, what you see over here on the right-hand pane is the deal. That's the deal. And I can't make this any bigger. So this tool does have its challenges. So if this really is the first sign of a problem, and I think it is, this is where we're going to splice the data out. Because I think if we go to track 57, 56, 55, 54, right. And by the way, what we're looking at is it's more than one track of data. So that separator, these white spaces are the separator here. And so here's the 16 sectors. 1, 2, 3, 4, 5, 6. It's sector 6 that's a problem. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Then there's a gap and it starts over again. All right, from 1 to 16. And of course, here's is the same. So this bad sector is the same as this bad sector. We're just looking at it twice. So if we change the scale here a little bit, then I can get it to fit on one image, one page. But that's just how this tool is. So now I'm actually looking at 0 through 16 all in one view here. So maybe that's easier. But what I'd really like, wouldn't that be nice if I could identify the hex here? What I wish I could do is just right-click and dump the hex. I can't even go over here and copy it because if I move my mouse, then it doesn't exist. So this is where what I'm doing manually here is definitely outside the scope of what this tool is designed to do. But we're going to do it. We're going to get it done. And thankfully, I only have to do this on 2 floppy disks, and I've already done it on 1. So this is by far the hardest one. So here's what I'm going to do. I'm going to do a print screen. We're going to do some silly image manipulation. And I'm going to take this piece of information right here, and I'm going to see if I can make this easy to see. We're going to call this the first bad sector. So this is the first bad sector. First bad sector. Right? Or is it? Next it. Yes. No. Next. It's the sector before the first bad sector. That's what I want to identify, is that. All right. So now how am I going to do this? Well, now I have this. I guess I could OCR it, but no. Here's another thing that's frustrating. You actually don't even see the entire ASCII text rendering here of the hex because it's cut off a little bit. So this is kind of interesting. Maybe it isn't. In this exact case, I think maybe it isn't. Next item, cancel to dismiss, volume, direct password. Oh gosh, documents. Chance L to dismiss, pattern. All right, so this is where it gets really painful. So we're just going to do some number manual copying here. Six, 5, 7, 8, 7, 4, 2, 0, 6, 9, 7, 4. Ay, ay, ay. 6, 5, 6D, 2C, 2, 0, 4, 3, 41, 4E, 43. And the third one, 45, 4C, 20, 74, 6F, 20, 64, 69. All right, so that's enough. What I have now is a string of hex. And now what I can do is I should be able to find that in both of these files. Hopefully it's a unique string and it only shows up once. So let's go here. This is the one whose beginning is good and the end is bad. This is the one whose this has the good ending, this has the bad ending. So really I need to find this in both files and hope it's unique. So here's what I'm going to do. I'm going to go to search, find, and we're going to change from text string here to hex values. I'm going to search the whole thing, and I'm going to paste in the string. We're going to search it all. And it says it can't find it. Well, maybe I typed it wrong. Let's find it here. Search all. Can't find it. Well, what do you bet I typed it wrong? Oh boy. So this is where it really gets fun. All right, so what we're probably going to have to do is 206E 65 7874 2069 74. All right, so let's temporarily put a line break there. All right. 65 6D 2C. Ah, there's my mistake. That should be a C. Okay. 204341 4E43. So you see, this is not for the faint of heart. It's a very painful process. And if you've watched this far, bless you. You really want to learn something, and you're not annoyed by the sound of my voice. So I thank you. 45, 4C, 20, 74, 6F, 20, 64, 69. Oh, yeah. All right, so I actually think that since I made one typo there, well, we didn't find it. Anyway, let's hope this is a unique string in both files. So over here again, we're going to do search, find, and I'm going to replace that, and we're going to do search all, and we find it a bunch of places. It's text. Next item, cancel. Oh, boy. So how do we know which one? Well, here's where I learned I didn't pick a unique line of hex. Oh, my God. Which is why I wish I could just take an entire sector, because chances are that's going to be more unique than just the first three lines. But since it's so painful to do this manually, you know, I'm almost tempted to like convert this to a PDF and OCR, but I have a feeling that that's going to cause some errors just because it's kind of a pixelated view, and you know, you might get character error that way, and maybe it's just as easy for me to do this myself. Oy. Just out of curiosity, let's go back to text string. How many times do we see the word pattern? Search all. Well, look at that. That was a heck of a lot easier. The word pattern only shows up there once? Really? Wow. Okay, that was a lucky guess. So here's what we're going to do. Just to make sure I'm getting this right, I'm a glutton for punishment. I'm gonna do this again just to make sure. 69, 73, 73, 29, 7C, 0A, 7C, 0A, 50617474, 65, 72, 6E, and then the last one. This is going to be our end point here, which, and I didn't want it to end up here anyway. 3A2020202007C097C. Now, if I didn't make a mistake there, that should be the very last hex pattern in this sector, marking the point at which I need to splice the files. Okay, so that being the case, let's see if we go back here to hex values, paste that in, select all, and we find it only once, right there, only once. I'm so thankful. And look, it comes right to the end of a line, which kind of indicates that it's at a very logical numerical place where this begins the next sector. And what do you bet that 489728 is divisible by the sector size of 256, huh? 489728 equally divisible by 256. Nope. Did I do that wrong? That should work. 489728 divided by 256. Yes, I did typo it wrong. 1913. So we're at sector number 1913 on the entire disk. I like this. Okay. Here's what this means. That magic number right there, this is where we're going to say this beginning is good, but the ending is bad. So now I'm going to hit the down arrow. I'm going to hit the shift key and the down page. Down page, the page down. It's late. And hit the delete key. And so now I've started a new file. Let me do file save as here. And we're going to call this the actual real IMG. Okay, there we go. All right. So now I need to find the exact same thing over here. And we should only find it once. And then just do the other half, splice them together, and I should have a file of the correct length. We're going to verify that manually. Search all. Oh, yeah, look at that. It's only here once. And this time, we see 485632. Notice that's a different number. We're expecting that. Why? Because an entire track ahead of that is missing. It's probably still divisible by 256, but it's less meaningful. We're going to find out. But we're just going to go all the way. So this, to all the way to the end now, should be the correct end of the file, because it's basically from here to the end here, and you see all this is all nice and green and happy on this image, whereas we've deleted this section here, but everything from here in on both sides are green and happy. So there we go. There we go. Alrighty. So let's get this done here. And end. Oh, what have I done wrong? That is not what I wanted to do. Edit, undo. Something's wrong here. Let's try this again. I'm going to close this, and then let's reopen it, because I don't want to make sure I didn't change anything on accident. All right, so this is the good second part. Yes, very good. All right, we're still good there. Let's try that process again. Search all. We find it only once. Right there. All right, so we're not going to delete this section. We're going to copy it. All right, so page down, all the way to the end. And now end. Now we're going to Control C for copy. And I'm going to do Control N for new. Now I'm going to, my cursor's over here in the hex, not over here in the decoded text. So there we go. This now should be the entire end section of the disk right before the bad section. And so what this means is now I actually should be able to, I probably didn't need to do that. I could have just pasted it here. And now we should actually have the reconstruction of the full disk without any errors. Isn't that fun? Well, let me hit save here, because I want to make sure I at least save the work. And let's let's make sure it's divisible properly. Now we start with 0 instead of 1, so I'm going to temporarily put a 0 here so that I can get down this this next number here. It helps my brain think. So this ends, since we count with 1 here in the real world, 630784. Well, that's a familiar number now, isn't it? All right, now let me get rid of this so I don't accidentally save an extra bit there or an extra byte there that I'm not supposed to. So 630784. Well, guess what? We're gonna do a little calculation here. These disks have we're gonna get to 77. How are we gonna get to 77? Well, every sector is 256 times 16. 256 times 16 times 2. See, that's better. 8192. I don't know how I got that other one before. 8192. So if we take this divided by 8192, we're going to get 77. And we do. There we go. My math is wrong. The file is correct, so long as I get rid of these extra zeros here to tell me what the number after this one is, because that's how the hex editor works. But we're going to hit save. And now we actually have the restored image of the entire dump of this disk. And so now we're going to encode it properly, because now it's just a raw dump. It doesn't have sector RP. It doesn't have sector size. It doesn't have RPM in there. It doesn't have bit rate in there. These things are all necessary in order to emulate or reconstruct this disk. So let's do a little cleanup here. And so now, in order to do this, we're going to use our very good tool here, HXC. What are we going to do? We're going to open the final image, which is this one right here, right? Yes, yes, we are. Okay, so we're going to load it. And actually, the way we load it is we load a raw image, because it won't let you load an IMG. It'll say that it's invalid, because it needs to know what this data is. And the IMG file is just raw data dump. It doesn't have disk architecture. So here's where we specify what the disk architecture is when we import the raw data image. All right. So this being the case, yes, track type is the IBM MFM. The defaults are pretty good here. Bitrate is 250,000. The RPM is 300. Yes, correct. Number of tracks is 80. Yeah, we'll leave it. And sectors per track. This is where we're wrong. It's 16 sectors per track, and it's not 512 bytes. It's 256. Thank you very much, Convergent Technologies, IWS, AWS, and NGEN. That's how you do this. And the rest of these things we will leave as default, because I believe they are correct. These are calculated from the numbers above. So there we go. So we're going to click Load Raw File. Oh, that's the one right there that we just worked on. Okay. Now we're going to have a look at the track analyzer. Go here to the dummy disk. It builds it. It looks perfect, of course, because, well, it's a fake, right? So there you go. So we start out with perfect data, not a single error on the whole thing. The question I have is, yeah. So, interestingly, it actually extrapolates the last 3 tracks. That's a good thing to know, because we'd only go to track 77. And so notice here, as we go between, there's a difference in what I call the filler. Whereas up to track 77, the filler is E5, right? The hex byte E5. And so starting with track 77, again, don't get thrown off. We start counting with 0 here. So it's tracks 0 to 76, which equals 77 tracks. Or it's tracks 0 to 79, which equals 80. So these last tracks, 77, 78, and 79, notice they're different filler. Well, they were put there by the HXC that reconstructed this thing. So here it is. It changes from E5 to F6. So those last 3 tracks, which are completely ignored by these Convergent Technology systems, IWS, AWS, and NGEN, are actually filled in, and that's fine. Had I specified 77, actually, you know what? Just to be clean, I'm going to do that. I am going to do that. We're going to load the raw image, and I'm going to say the track number is 77, 2 sides, 16 sectors per track. We're going to load the raw image here. Now it's going to look just right. And we're going to go to our track analyzer. And look at that. The last track found is 76, right, which is the 77th track. And there's no extra filler. Those last three are just kind of a darkish black there. Yeah, we're going to leave it like that. I like that. That's the way it should be. And so that's actually how we've now reconstructed this disk. But now we've got to save it in our usable formats. So we're going to go here. We're going to click Export. And we're going to save it in two ways. First, we're going to save it a BitSavers friendly way, which is the Dave Dunfield's image disk, IMD. Okay? And so I'm going to get rid of this second IMG there. All right, we're just going to save it as IMD. Reuse my base naming convention. There. All right, and save. And I'm also going to export it as an emulatable file, emulatable by the an emulator file for the HXC and the Gotek and various other compatible floppy emulators. And so the HXC file is HFE, I believe, is the default. Yes, and notice that because this is HXC, it exports by default its own format, which is HFE. So we're just going to change this, get rid of that extra little 3-letter there, so I have a consistent naming convention, and we're going to save. And so now we have properly converted this disk, and now we have it to two formats. We have IMD and HFE, and we should be able to open both of them and see that our track is preserved. So let me do a little cleanup here, get rid of these backup files that were created by HXD. We have too many HXs here going on. HXD is a hex editor, whereas HXC is a floppy emulator. No confusion there. I almost deleted that HFE. Let's not do that. Anyway, so if I were to open the HFE file, it would say, yes, I recognize exactly what you are. This is native to me. An HFE file is native to HXC. And we go to Track Analyzer, and we go to our dummy disk view. We're going to see that same exact beautiful thing. And we're going to see exactly the same thing if we load the IMD file right here, because it's a pretty good tool. It interprets both of these things the same way, and they are the same. Okay, but anyway, but you can't just dump an IMD file, an image disk, Dave Dunfield's image disk, into an emulator. You need the HFE file for the Gotek and for the HXC emulator. So that's why we're creating both of them. So there it is. You've watched the very long, lengthy process now, which took me 34 minutes to manually restore manually splice together two partially good captures of a floppy disk. So if you've watched it to the end, I want to congratulate you. I want to thank you for watching. You are a true fan, and we really, very, very much appreciate you watching and learning. Let me know in the comments that you actually watched it to the end. I'd like to hear what really interested you about this conversation and about this tutorial, if you will, or overview. All right. Thanks so much for watching. Till next time on Forgotten Machines.